Yes,
Long
sir.
time.
Yes, sir.
I'm doing good, sir. Thanks for asking.
I'll speak to you.
Sure.
Unmute your audio, ma'am. Divya, madam. Unmute your audio. Yes, you can.
Sorry. A very warm good morning to you all. It is my great pleasure to welcome you here this morning to this fourth day online Global Faculty Development Program organizing by Department of CSC VGIT. I now request Professor B. Srinivasulu, sir, Head of the IT Department, for a formal welcome. Over to you, sir.
Yeah. Good morning, one and all. The guest for the last 4 days, Jyoti Periswami Garu and Dr. Geeta Garu, for spending their valuable time. So, on this occasion of 4-day global faculty development program on artificial intelligence and data engineering, so I hope with the current pandemic situation of COVID-19, I think market is taken over by artificial intelligence. I think all of us knows that, right? And even as likely pointed out by Mr. KTR, from Telangana. So year 2020 is for in the name of artificial intelligence. So with that kind of a note, maybe so if you just go through last 3 days kinds of presentations. So day one was handled by Mr. Jyoti Periswami Garu with regards to artificial intelligence and in real world applications. So how to apply artificial intelligence in real world applications. So day two was handled by Dr. Geeta ma'am, which she dealt with regarding to machine learning and its kind of applications and importance in artificial intelligence. And day three followed by again Jyoti Periswami Garu. So with regards to time series data analysis using machine learning, so which is called using predictive analysis kind of a thing. So today again dealt by Jyoti Periswami Garu. So the role of data engineering in artificial intelligence. I should really thank both Periswami Garu and Geeta for spending their valuable time in spite of their busy schedule. I also thank Durga Prasad Garu for taking his time to join this session. So, officially I welcome you, sir, Jyoti sir. So, hand over to you, sir. Thank you. Thank you. Thank you very much.
Thank you, sir.
Thank you, sir. So, without taking much time,
Yes.
I hand over this session to Mr. Jyoti Periswami. Over to you, sir.
Thank you, madam. I will definitely take it from here actually. So can you give me 1 minute? I just have to take this call. 1 minute.
Okay, a small instructions to all the participants. You will be given a quiz followed by feedback by the end of the session. Kindly fill it and make sure you enter your details in a correct manner so that it is easy for us to generate e-certificates as well. If you have any queries, you can enter or you can post your queries in the chat box, or whenever the speaker give time to ask questions, you can unmute your mic and ask question, or else you can raise a virtual hand so that we unmute you. Thank you.
Sure. Thank you so much. So I just have to go. I'm going to request DP. Can you pull the quizzes from LMS and formalize more of a structured form? Put about 25 questions. And
yes, sure. I'll do that. Yeah, I'll do that.
Yeah. So take directly from the LMS and form about 25 questions and put it in more structured, the way we conducted for the summer boot camp, where they can record answers and everything.
Okay.
Yeah, in that form. Thank you.
So, will you do after the session or
No. We want to send it to them. We wanted to send it to them after the session. You stay 30 minutes. After 30 minutes, you can drop and start working on it and send it back to me as soon as it's done. It shouldn't take too much time.
Yeah. It covers all the topics, right? So, what topics should I cover?
All units.
Okay. 25 quizzes. Questions.
Yes.
Covering all this. Okay.
Yes.
Sure. I'll do it.
Okay. All right. So sorry for the disturbance. Thank you so much. It's definitely been a big milestone for us for the last 3 days. I know for me, teaching virtually is not a big deal. I have been doing this for almost last 10 years, I would say. For But for you with the family, kids, and taking some time to come and attend the class is not easy. And I really appreciate the time you're taking coming and attend the class. And I also want to sincerely thank you, the VJIT team, principal, HODs, faculties, coordinators. It's such a pleasure to work with you all. I truly enjoyed, and I'm really looking forward to working with you all. Thank you. With that said, let's move on. So today we are going to focus on data engineering. I am confident, positive. There's no one in the industry teaching this topic. Okay, why? It's number one, it's a very heavy topic. I'm not saying that people are not out there, but it is quite complex. There's so much involved, you will get to see. Handling all and making you to aware, it's not that easy. So it's one of the very unique topic and also very critical and key topic. If you want to be an expert or a subject matter expert or a teaching professional in the field of data science, in the field of artificial intelligence, which covers machine learning, deep learning, computer vision, natural language processing, robotic process automation, this is the must and mandatory skill for someone to have. Okay. Without this skill, it's like I am a surgeon, but I don't know how to do surgery. That's what it means. Okay. So it's an absolute critical must skill to have. Like I said, it's not easy, especially teaching professionals like you, getting into this type of deep dive technology oriented learning curve. It's not an easy task. I really appreciate this one. So we will go to focus on data engineering. So before that, what I want to do, since we ran out of time yesterday, I couldn't complete the model, what I was trying to teach. So I'm going to quickly cover that today, run the demo, then we'll come back here. Okay. I'm okay from time perspective, even if it takes some little more time, it's okay. So what we talked in yesterday's class, we talked about how do we implement linear regression. So what is linear regression? Geeta madam taught us there are different type of problem we can solve using machine learning. So problem one, a classification problem. Predict whether this is a male or female, true or false, yes or no, 0 or 1. You are classifying a given problem. So that is one type of problem we solve using simple machine learning. Second, Geeta Meltham also told in a regression problem. What is regression? Classification is 0 or 1, true or false, yes or no, male or female, etc. The regression problems are range of value. What is the salary of Dr. Divya? 50 lakhs to 75 lakhs. What is the salary of Durga Prasad? $100,000 to $200,000. Okay, so that's the range you define. It is not a defined set of classified values. Okay, it's a range, and that is the model we are going to implement today. Okay, why do we need this model? Our objective is to predict a 6-month rolling forecast. What is the 6-month rolling forecast? We already looked at. At what level we want to do? We want to do it at a SKU level. What is the SKU? Stock keeping unit. That's the lowest level in a product. Okay, so all of those we discussed in the last session, and this is where we had some challenges in, like, screen sharing and all. We stopped it. Okay, all right. So how do we implement this model in a practical real world? So what are the steps involved? Step one, an INI file configuration. What exactly it means? Okay. So this basically tells you any dependent library, any file that you want to use, you don't hard code in your source code, use an INI file. That's what this means. Okay. So this is basically an efficient way to write program, code, etc. That's what this INI file, but for now you could ignore. Second, import required libraries. So what exactly we are trying to implement? We are trying to implement linear regression. Where is that model? So that model is available in an open source machine learning library. So what kind of machine learning library that we can use? We can use Google open source TensorFlow or a scikit-learn. So those are the library we need to implement. So this step 2, try to implement or import those kind of library. Once it's done, the immediate next step, what we talked about it. All right, now we have to train the model. How do I train? I need a training data. Let's import the training data. Once you train the model, now the model is trained to do a 6-month rolling forecast at a SKU level. Okay. Then the next step is test the model. See how the model is performing based on the training that what you provided. Okay. I'm expecting in the region of Asia Pacific, in country India, city Hyderabad, the product that I want to sell is a printer. How much I'm going to sell in the month of January 2021? $100,000. So that's the expected prediction. But how much the model is predicts? But the model is predicts 45,000. What does that mean? The model is underperforming. So now I have to continue to train. All right, I retrain the model. I'm going to redo the testing. When I redo the testing, this time what the model is supposed to predict? The model is supposed to predict $100,000, but this time it predicts $200,000. What does that mean? It overperforms. Okay, it overperforms. All right, something wrong. I'm going to retrain the model. I'm going to do retesting. So now I'm expecting the model will function. This time, how much the model is predicts? The model is predicts about 98,000. Yes, it's kind of close to regular performance. So this is what we talked in the last session. Regular fit, underfit, overfit. Okay, regular fit, underfit, overfit. So that's what the testing of the model takes place. Okay, the testing of the model takes place. Okay, so this is basically the model training and testing the model. It's here. Once that is done, and run the forecasting and see how it looks. If the forecast looks good, write the model to an outcome file. Once you write the outcome file and see the outcome file, how it's been written. So this is basically a high-level implementation step. So now I'm going to the live demo. Okay, I'm going to the live demo. I'm going to stop the screen and I'm going to go back and share a different screen. Okay, so what I'm going to do, I'm going to go back to share the code block that is written. Okay, so this is the, no, I don't want this one. Yes, so this is the one I'm going to show you right now. Can you see my screen?
Yes,
Can anyone? Yes, okay. So what you're looking at here, this is the Python program. Okay, step 1, INI file configuration. Step 2, import the required library. I talked about scikit-learn, sklearn. That's what. Linear regression, that's a model we are implementing. Import the training data. The training data stored in my local drive. I'm going to open and show you. All right. And then the next step, it talks about the model that is required to be imported. I'm doing this. Okay. I'm doing this one. And the next one is train the model. The next one is test the model. Okay. This is my test data. This is my test data. All right. Once this is done, the model is going to run the forecasting. Once that is done, the model is going to write the outcome. Once the outcome is done, then I'm going to see the outcome and then write the file and everything. Okay, so this is the complete code block. Okay, you can see what it's doing. Okay, you can see them, everything that's whatever it's doing, it's written here. All right, so now let me show you the training and test data so you can understand. I'm going to stop the screen, go back and look at the training data. So this is this place where you can see this one. I hope you are seeing my screen. You see there's a training folder, there's a test folder. So I'm going to go ahead and click on training. And this is my training data. Open this one. Okay. So what is my goal? My goal is basically train the machine to understand so that the machine can forecast 6-month rolling. Okay. 6-month rolling. So I have 6 months worth of rolling forecast data. So that data is the one I'm going to use for the machine to learn. Okay. Okay. Hopefully 1 second. All right, can you see my file? So this is my training data, okay? So this is just basically a simple data that's been given to understand, Okay, so if you recollect some of the discussion that we had yesterday, so how this has been organized. So this has been organized in a hierarchy: product family, product group, product, and then the SKU. Okay, product and then the SKU. So that is where we are going to sell. So what we are going to sell, we are going to sell this, we are going to sell this. So the company wanted to predict how much we can sell. And this is in time series. When I say time series, it has a year, it has a month, and it's a timestamp. And what we are going to sell, these two guys. Quantity, how much we are going to sell in this one. Okay, so rest you could ignore, unit price and all, that's really not that critical. Okay, that's for some other purpose, calculation, intelligent automation. If you read this one, in the region North America, country United States, city, state Washington DC, states Seattle, customer Walmart, product, this is telecommunication thing. Okay, so components of IT telecommunication, that's a product group, it's a product family, product group, and then the product. Okay, and this is a SKU. And this product and the SKU, it's going to be, this is an actual data. Year 2015, month of January, this time we sold this much quantity, this much SKU. Okay, and under the unit price, under the item count, and etc. So this is basically the training data for machine to understand what has been sold in historically last 10 years, 5 years, whatever this is, right? You can give this one. So now the machine learns and understands what has been sold in a given region, country, state, city, time, etc. Correct? Now it learns and understands. So this is the data I'm giving the machine to learn. All right. So now I want to test this one. How do we test? Now I have to look at my test data. Okay, I have to look at my test data. So I'm going to open my test data. 1 second. So this test data is basically in a different folder. This is my test data. So can you see the test data, or I have to stop and reshare?
No,
Can
sir.
you see this? Can you see, ma'am?
No, sir.
Okay. So I'm going to share the test data now. So you can see the test data. You see this one? This is my test data.
Yes.
See my cursor? It says test data. I'm going to enable editing. So in the test data, what I have, correct? I have everything. Okay. It says screen sharing has stopped as the shared window is closed. Okay, hold on. I accidentally closed, looks like. So now, let me go back. Can you see my screen now? Test data?
Yes, sir.
Okay. So this is basically the same training data that what you have seen, except the quantity, the unit is the number of quantity that what we are selling. Everything will be there, except because that's the value that we want to predict. You see this one? It has all the things. Okay. The first 4 or 5 column talks about the location where we are selling. The next 4 or 5 column talks about the product family, product group, product, and the SKU. And then the time series, in what time period it's been sold. And then you'd see this one, item count, unit price, it doesn't have the quantity that's sold. And that is what we want to predict. Okay. So we want to predict in each of this location, under this product, in this time frame, how much we are going to sell. So now the model has been trained. A subset of the training data has been taken. In that as a test data. So we took the subset of the training data as test data. It's typically 70-30, 80-20. That means if you have 100 record, you use 70 record for training, 30 record for testing. Or you could use 80-20. You could use 80 record for training, 20 record for testing. So it's the same exact data, except the target variable that you are trying to predict, it's not there in the test, okay, which is there in the training, okay, which is there in the training. And if you recollect, as Geeta madam said, this is the label that we wanted to predict. Okay, all right. So now it is not there. So we looked at the training data, we looked at the test data. I'm going to close this. So I'm going to, come on. Okay, so I'm going to open the model outcome. Okay, so give me a minute. I'm going to open the model outcome and I'll share with you. All right, so let me close this. let me close this. So hopefully you are able to see the model outcome now. I'm going to share the screen in a minute. All right, so I'm going to share the screen now. So, okay, there's something went wrong. It is not letting me to share. I have to rejoin the meeting again. Okay, give me a minute.
Dear participants, if whenever a speaker changes the screen, can you see that? Because I'm receiving some messages from some participants saying that they cannot see. If anything like that, please let us know.
Can you all hear me now?
Yes, sir.
Okay, so I apologize. We have to live with what we have. So that's all this is. Okay, let's move on. So I'm going to share the screen right now. So I'm going to share the folder that where I have the model outcome. Okay, so can you see now? So this is basically the place where I have the model outcome. You see the output? These are the files. Okay, so now I'm going to delete this one and rerun the model so that you can understand these are all the model creates this now. So basically it does the 6-month rolling forecast, and also it predicts the product quantity, and also it predicts the SKU quantity. It does the forecasting, it calculates the revenue. So basically all are done by the machine without any human intervention. And that is why we talked in the beginning. This involves an intelligent automation. An automation occurs by itself. And also this allows to dig deeper and get insights, okay? Such as time series analysis, what we talked about, trend, cyclic, irregularity, seasonal, correct? It pulls all of them together, okay? It pulls all of them together. So I'm going to stop and share a different screen. Unfortunately, that's how this works. Sorry for that. I'm going to stop here. I'm going to bring in another screen. Give me 1 minute. So I'm going to share the screen now. So can you see my screen now? So what I'm going to do, I hope you are able to see. I'm going to delete all the output files. Okay, I'm going to delete all the output files. I'm going to go to open, browse, and go to the specific folder, which is in my desktop, FDP, and output. I'm going to delete these files. Okay, so you can understand. So I'm going to delete all these files. Now run the model. So when I run the model, it should create all these files. What it is predicting, it does a 6-month rolling forecast. And also it does the prediction of quantity that what you sell under each region, country, state, city, and product family, product group, product SKU, time, and etc. And it also do the forecasting. Okay, not only the 6-month rolling forecasting, regular forecast. Okay, it does this one. I deleted, I'm done. Okay, I'm deleted, I'm done. So now I'm going to stop and share a different screen. That's when I'm going to run the program. I'm stopping now. I'm going to share the different screen, the screen that what we looked at. Okay. So this is basically what the screen we looked at. Okay. So what is this? This is the program written we just went through. And as needed, I will send you the source code and also all the file that is required. Anything, everything that required, you could redeploy. Okay. Sky's the limit. If anyone interested, because we all wanted to be a subject matter expert. We all wanted to be as much hands-on as we could. The hands-on makes you very valuable, and also no one can fool you around. Okay? Otherwise, people can talk nonsense and we'll get irritated. Okay? So in order for us to be smart enough, hands-on, a good subject matter expert, I would encourage you to practice this. Okay? It's not rocket science. Like, we have given you everything. Okay? We have given you everything: source code, problem statement, models, files, outputs, etc. You just have to spend 1 or 2 hours to connect all the dots. That's it. Okay. So now first, what I'm going to do, I'm going to clear everything. You see, the model has been already ran, and that is why you see a lot of outcomes here. Correct? These are the output it created. Okay. So I'm going to go ahead and clear this one. Click kernel, under kernel, restart, clear output. Yes, I'm going to restart and clear all the outputs. So now it's going to clear all the outputs. Okay, it's going to clear on the background. It's running. It's going to clear all the outputs. Once the output is cleared, you can see there's nothing there. You see this one? There was something that displaying here, all the product and etc. Those are all gone now. I'm going to rerun the model. Click kernel, restart, run all. So it's confirming, run all. How do you confirm whether it's working or not? You can see it puts a star in front of all the cells, like, so that confirms that the model is running. You see the star? So that means it's running now. Okay, that means it's running now. It may take few minutes. So this is basically an intelligent automation. Anything, everything that's required. Okay, whatever required for the model to run, it's all fully driven, either in the form of an INI file or in a table or whatever way you want to code. That's fine. Okay, that is fine. So now the model ran, it produced the outcome. It produces the outcome. Okay. So some of them are still running. You can see here, in some cases, it ran for a first block. It could be at a SKU level. Then it could further down, go on, create for other outputs. Okay. It's still running. You see the star? That means it's still running here. Okay. I'm waiting for this to run. So once it's finished, we can go back and look at the outcome file. Okay. We can go back and look at the outcome file. Yes, it ran successfully. It created output file. Okay. So what it is doing, it's doing a 6-month rolling forecast. It predicts the value of the quantity what you sell by region, country, state, city, and product family, product group, product, and SKU on a time level. On a time level, it does everything. Okay, you can see region, country, state, city, and customer, product family, product group, product SKU, year, month, time, item count, and also do the forecasted quantity. Okay, you see this one. It does. How do we see this outcome? So the place where I deleted the file, I'm going to go back and look at now. I'm going to stop and share the different screen. I'm going to stop this. I'm going to share a different screen. Okay, so I'm going to select this guy and do share. So now I'm going to open this one. Go to file. Under the file, I'm going to go to open and I'm going to browse. And here, the output file. These are the files I deleted. Now you could see it just created. Okay, the time is 10:29. It created 10:28. See this time? So this is the files it's created. Okay, so what I'm trying to say, whatever you need, we already built. Okay, we already built. Your job is to take this and just configure and run it. So now you feel the real essence, how the prediction takes place. How does the machine learning model works? I can bet there are so many training institutes out there. Okay, I don't want to name. There are online courses out there. There's no one can come close to what we are doing here. Nobody in the globe, for sure. Okay, it's a great opportunity for you. How far you want to go? Okay, how far you want to go? If you build 1 or 2 model, you truly understand how this works. If it is not, you may know as a concept, but you may not have a confidence to teach or even speak. Okay, how does this work? Because everywhere what you see, a lot of mathematical equations, a lot of statistical definitions, correct? In the real world, it's not required because these are all already known. Why do I need to study about decision tree too much? Why do I have to study about logistic regression too much on the math and science? All I have to know, how do I apply this? Okay, how do I apply this one? And that is what the real key. And this is where the real money too, correct? Why industry is paying top-notch salary for these people who knows these things, not everybody, correct? Because this is the piece missing in industry right now. How do you take a problem and build end-to-end everything, correct? So that business can get to see the value. Okay, so as a last demonstration in this context, how does you take to the end user? Okay, I am a CFO. I wanted to see the planning, budgeting, forecasting on a different level, not what we are doing. Okay, how does that work? Let me show you that too. Okay, let me show you that too. So I'm going to basically, excuse me, sorry, stop the screen and share a different screen. Okay, so hopefully it's there. Okay, 1 second. Looks like I closed it. Give me a minute. I'm going to open that screen, but meanwhile, you can watch this. Okay, 1 minute. I'm just going to open a different screen. Yes. All right. Can you see on my screen? Can you all see my screen?
Yes, sir.
So this is the end product what we developed. Okay, whatever model we implemented, an outcome of that model, there is an end product that has been created. So this is a live system. Okay, what you're looking at, it's a live system. So what exactly it's doing? It brings all the data together for people to analyze this one. So what they're saying, if your sales is going to go 2%, if your sales is increasing, and how do you calculate your gross sales or gross profit? You see the numbers are changing. That's a prediction. That is a prediction on the back end. Okay, on the back end, it runs these models and tells you what is the cross sales, what is the cross profit, what is the net sale, okay, based on this. And it also allows you to look at the data at a different level. Okay, how do we look at the data? Different level. I can look at monthly, I can look at quarterly, I can look at yearly. Okay, so I can look at yearly, monthly, this. So what I'm looking at, okay, I'm looking at my net sales. I also want to look at, correct, how much expenses, revenue that I'm going to get. And I'm also want to look at operating expenses. I want to also look at cost of goods sold. So you see all the numbers are changing, plan, actual, all the things what we discussed, those are all behind the scene. And see the prediction. Okay, what is the prediction? If my net sale goes down, okay, how does it going to look? Okay, you see this one. Okay, so this is what a real AI solution or data analytics solution or a data science solution, okay, or a data science solution. In a real world, whatever model you run, the model outcome should be brought to that level, okay, should be brought to this level. So what are we talking about? When my sales goes up, okay, how does my revenue is going to look like? If my sales goes 2% down, how does that look? If my sales 2% high, how does it look? You see these numbers? This is the number I'm talking about. And this is a time series, okay? This is a time series. October, November, December, January, etc. I'm looking at on a monthly basis. What is my plan? What's my actual? What is the variance, correct? If my sales goes 2% down, and how does my variance looks? If my sales goes 2% up, how does it look, correct? I can see this in real time. I can see this in real time. And this is what real world data science applications, real world machine learning applications, okay? So for example, I want to look at in a budget allocation. how much money I want to allocate. Okay, I can't randomly allocate. I want to allocate based on some of the activity that has been happening. Okay, so I want to allocate based on some of the activity that has been happening. So I can choose the allocation based on this one. If I'm going to allocate another $100,000, for the $100,000, what is the cost I'm going to get in the month of January to April? Okay, you can see this one. You can see the numbers are changing. Okay, so these are all predictive model. Based on the budget allocation, there is a correlation between what you are selling, what you are predicting. Okay, so these type of application, what business interested in a real world. Okay, these type of applications, what business interested in a real world. So what we have done today, or what we discussed so far, building these kind of real world application for industry. Who's using this kind of solutions? People who's in the finance department, people who's in the sales department, people who's in accounting department. Those are the people using this solution. And here I am doing anything, everything completely using machine learning, artificial intelligence, data science. All right. So this is the day 2 session, which I wanted to cover. I could not. Okay, I could not because some of the time constraint and technical challenges. Any questions on the real world application, what we looked at, how machine learning applied from a problem statement all the way down to an end-to-end solution? Any questions? Do you understand what we have learned so far? And as it said, there could be 100,000 million institute who can teach this one. I am confident no one can come close to this level of clarity so that you can get and see how it works in front of you. You can touch it, you can feel it, you can understand this. Any questions? Do you all understand? All right. So I'm going to move on to the next topic. I'm going to stop this. And DP, if you want to drop the call, it's fine. Okay, so we are going to go and focus on data engineering. Okay, as I said, this is one of the heavy subjects to handle and teach. Okay, so this is one of the heavy subject to handle and teach. Okay, 1 second. Dr. Ranga is saying something. Okay, all right. What we want to talk in data engineering, there is so much involved. Like I said, it's not that easy to handle in 90 minutes, but I want to give a framework so that you could understand. So first we need to understand what is data engineering. Okay, so please think through. I will ask questions. So in that context, we do need to understand what is data collection, what is data streaming, what is data integration, data mapping, data conversion, data provisioning, distributed data processing, in-memory data processing, real-time data processing, working with various data structure, data quality, data governance, structured data processing, unstructured data processing, machine data processing, sensor data, image processing, audio processing, data source, data target, source systems. Okay, I'm not limiting only this. At least in my industry implementation, these are the things I learned part of data engineering. Okay, I learned part of data engineering. So at least if you master these things, you are in a good spot. If you don't understand all the things, both functional and technical, it would be challenging to teach this subject. Okay, so based on your assessment, what do you think as a highly paying job in the current industry trend? Okay, is it artificial intelligence or data science or data engineering? What do you think is a highly paid job? Okay, it's just a good to discuss. Okay, someone thinks artificial intelligence, somebody thinks data science, somebody thinks something else. I'm just asking you. You can post your comments in the chat window. Okay, what do you think a highly paid job and highly challenging job in industry? Of course, teaching is there, correct? So we all teach, okay? So combination of all right. That is from RRS, Ravi Kumar. Thank you, sir. Appreciated. Anybody else? Anybody else? Obviously, yes,
Jail
please.
Singh Bhukia has answered as data science.
Okay. Yes. So if you see here, yes, ma'am. Thank you. If you see here from the day one, what we talk, it's an interdisciplinary study. What it means, you can do artificial intelligence without data. You can do data science without data. See, in both the cases, either if you want to go and become an artificial intelligence expert or a data science expert, the expectation, the underlying expectation, you must know data engineering. You must know data engineering. And that is why those kind of jobs are highly paid. If you are not a data engineer, you will be thrown away at the max 2 to 3 weeks. That's it. Okay. So I have received a lot of requests. I want to get involved in industry. Where do I start? I know Python. I did some R programming. I took some course in Coursera. I took some course in EDX, whatever that is. Correct? Will that make you a highly paid resources? Or it doesn't matter money. Will that make you feel you are a confident subject matter expert? Answer is no. Answer is no. Why? You must have to really understand data engineering. In both the cases, whether you want to be an AI expert or a data scientist who's heavily focused on building analytics or extraction of insights from data, if that's what your focus, regardless of what your educational background, whether you have PhD or a master's or bachelor's or what you do, the expectation is you must have to understand data engineering. In that context, all the things what we listed here, it's absolutely critical for you to understand both functional and technical. Functionally, you should be able to speak. Technically, you should be able to talk about it. All right. With that said, let's move on. So these are the topics I'm trying to cover at the best what I can, I could. Okay. If I'm not able to, don't worry. We will have some other session and we will take it from there. Okay. All right. Now, my first question, it's an assignment. Okay. It's an assignment. What is engineering? Okay. I will answer that question. It's easy for me. What I want you to answer, okay, in the chat window, even one person, I would really appreciate. Okay. I would really appreciate. Whatever you understood from your point of view, tell me what's data engineering. Okay. Typically, engineering, it's a production. It produces something. It makes things available. Okay. So a mechanical engineer working in Tesla makes car and building car and making that car available. A civil engineer make the building available for someone to go and live. Okay. An electrical engineer making electricity available for people to use. Okay. See the word making available, making available. An engineer, okay, an engineer makes things available for people to use. That is what fundamentally what we learned so far, what is an engineering discipline means. Okay. I cannot tell someone who's studying English literature, go on, make a car in Tesla. It's not an issue in the skill. It's a subject what we study. Okay. I cannot take someone who studied economics and put them into create an electrical switch, which is going to control the electric power. I can do. Why? The field of study is different. When you study an engineering field, such as civil, mechanical, computer science, whatever you name, the expectation is you make things available. You produce things for public to use or consumer to use or use something somewhere. Correct? That is what, by definition, what an engineer does, what engineering does. In that context, I need someone from this class. What you understood, or what is your definition of data engineering? It is not very difficult. It's just a one word I'm expecting. Can anyone tell? We'll take 2 minutes. Put your response in the chat window. Okay. So I have someone from Deepali. Extraction, preparation, processing, analysis, production on data is data engineering. I do agree partially, but I'm just looking for a specific word. Okay. Anyone else? Excellent. Okay. So I don't want to mispronounce your name. I'm going to call Jail, Jail Singh, I believe. Making data processing. Okay. Excellent. Processing is just a one word, correct? But there are many other things involved. I like the making data. Okay. Divya, processing data. Like I said, I definitely like that definition. Okay. Processing just a one function, correct? Processing just one function. Kushma, developing information system. Again, it's a very broad generic term. Okay. Developing information system involves many things. We are exclusively talking about data engineering. Okay. So RRS Ravi Kumar, it can be capturing, integrating, analyzing, mapping data. I do agree, but there is one specific word. All right, excellent. I really respect all your responses. It's great, wonderful, not an issue. Okay. I can see you're all very engaged. I really like this one. I can see from Ratika. Okay, all are wonderful. It is very simple. Okay, it's very, very simple. So that is the reason I used make available, make and available. So what it is by definition, I'll come to this one. Traditionally, what we do, okay, traditionally what we do, we use extract, transform, and load approach. In a modern engineering approach for making data available to business user to perform analytics, reporting, data analysis, or application is data engineering. Okay, what it is, making data available. Okay, making data available. Okay, making data available. That is what data provisioning. Okay, all the thing what you said is right. The one that I was looking for in a simple definition, an engineer make things available. As an engineer, you produce something and make it available. And that is what fundamentally what data engineering. Data engineering is nothing but make data available for analytics, application, reporting, etc., etc., etc. Okay. So what does that mean? We already have that things in place. Okay, we already have that in place, correct? So is it that we don't have any reports now? Yes, we do have reports. Is it that we don't have any analytics or application? We have all of them. What is the difference? In the current traditional approach, we follow a methodology called ETL, extract, transform, and load. And that's just an example that I'm giving you. But when you go for data engineering, you may not use the same thing. Use a modern approach. What is the modern approach? Instead of a human intelligence, you'll use machine intelligence to extract, transform, load, and make data available. Okay. So if anyone asks you, what is data engineering? And an engineering discipline applied on data and make data available for reporting, analytics, application, etc. That is what by definition we should do. All right. What kind of data that we are going to work on? We already talked in the last class. These are the different type of data we will work with. We know what is a structured data. Okay. A data which is stored in a database, which has rows and columns. Okay. So that's kind of a very structurally organized. Unstructured, the data start is organized in a table form. It could be free form text. It could be anything. Okay. It could be anything, but still we have to process the data. Semi-structure we talked about, like something like an email, it's a very semi-structure. A formal letter, it's a semi-structure. YouTube videos, there's no structure, it could be anything. Images, it could be anything. So a data engineering, which deals with all this kind of data. Okay, all this kind of data. So basically data engineering works with what type of data? It works with all this kind of data. It works with all this kind of data. I have an assignment question here. Okay. So this will definitely make you think really well. How to connect or integrate all these 6 type of data. Okay. How do we connect and integrate all these 6 type of data? Second question, can you give me one use case where we need to use all these different types of data? I will give you one use case. I told you in the last session, conversation-based customer engagement. Okay, conversation-based customer engagement. That's a use case. In that case, when a customer walking into a store, let's assume that you're going to a Reliance retail store. Let's assume that you're going to a Walmart store. Okay, whatever the retail store that we have in Hyderabad. When you go to the store, there's a digital board in front of you. It welcomes you. You can see your picture there. It tells you, hello, Dr. Divya, how are you? I'm doing wonderful. We have some promotion for the things that what you bought last time. You bought a necklace. This time, the same necklace we are giving for 20% off. Would you be interested? It builds the conversation on the fly. You don't need a sales rep. You don't need salesperson in the store. It understands who you are through facial recognition. It builds the conversation using natural language processing, and it interacts with this one. That's an application I'm working and doing pilots. Okay, in a pilot mode. In that application, I get the customer information from CRM. That is a structured data. What the customer likes, don't likes, that I'm getting from Facebook kind of a unstructured post. Semi-structured. If the customer written an email to the store as a complaint of a product or service that has been provided, that I can check in the email. Okay, that I check in the email. Videos. If customer is being pissed off because the product was not delivered well, the customer took a video of the product and published in Facebook, whatever it is, then I need a video. The customer didn't publish a video, they put an image in a Facebook and told, wow, awesome, I love this, it's great. So voices, the customer don't want to publish anything, they want to create an anonymous voice and publish, correct? So in that context of constant conversation-based customer engagement, we use all this data, okay? We use all this data. Number one, when I talk about customer, something like you already been to a retail store, you are going back again. When you go back again, the system understands this customer is known to me. Under the circumstances, the customer has to pull your profile. That profile is in a CRM system, that's structured information. What the customer likes, what the customer don't like, what the customers like, feedback about certain things, that I can get it from Facebook or Twitter, any other places. Social blog. If the customer made a complaint that comes in the form of email or a feedback, I can pull this in process. If the customer publishes a video about this product, I can see this. Images, voices, I can do. So we use all different type of data for this one use case, which is called conversation-based customer engagement. You can see this live in India, maybe in a year from now, okay? When you go to a retail store, when you go to any store, you don't need human, okay? You don't need people sitting there and welcoming you, talking all the things. Instead, you see a digital boardroom, something that where you can where you can see how these are going to work together, okay? So point what I'm trying to say, in order for you to work with these kind of data engineering principle, you need to understand all different type of underlying data structures. All right. So in that context, I have two questions. Number one, how to connect these 6 type of data for a machine learning use case. That is one thing. How do you connect? Okay. One is table, one is social block, one is video, one is image. Okay. It has to link to a customer. Okay. It has to link to a customer. So typically a customer has a customer ID. How do you connect all the things? That is first question. Second question, can you give me one use case? In my session, I told you about a conversation-based customer engagement. Like this, you can also give me one use case. Okay, you can also give me one use case. Let's move on. So we talked about data engineering, we discussed. All right, what is the framework of data engineering? And this is what you all put in the chat window, okay? You all put in the chat window. What is the actual framework, how it works? So a data engineering starts from the source system, from where we are getting data.
The data comes from SAP, Oracle, Microsoft, Facebook, Twitter, YouTube, device, file, sensor, others, etc. Okay? No matter where they are. A data engineering framework should connect and read the data. Okay? So this system that what you're looking at the bottom, that is called source system, from where we are getting data. Within this, what kind of data we need, that's a source. Okay? System is different, source is different. The next is a data engineering should be able to collect all this different data. The next is a data engineering should be able to prepare the data. When I say prepare the data, what does that involve? Conversion, etc. Okay, I didn't put all of them. Once it's done, then do validation. Okay, so validation is not a new term, it's been there. Typically what you validate, I need some response from the participants. When you talk about data validation, what is that we do in data validation? Can anyone tell, please? Okay, what is that we do in a data validation? Can anyone tell? So in a data validation, I said it's not a new term, it's been around quite a while. So what we do in data validation, any idea? So this is where we check the completeness, accuracy, integrity. Okay, so what we do here, so we check data completeness. Okay, so what I'm asking for, the data validation involves, okay, completeness, okay, accuracy, integrity. So these are the things we look for in the data validation process. Okay, so during data validation process, so what we look for accuracy, we look for data integrity, completeness. So whether the given data is complete, yes or no. For example, I'm asking your full name, but you just gave me only your first name. So that is not complete set of data. Okay, that's not complete set of data. Okay, so you are giving only partial data. I want your first name and last name, but what you gave me only the first name. Since I don't have the full history, then I'm going to basically assume you have not given a full data. So that's the completeness. Accuracy. Okay, I'm asking for the distance between Chennai and Hyderabad. Okay, so the one you gave me about, it's about 10,000 miles. That's not accurate. Okay, that's not accurate. So I need an accuracy. Integrity. I asked for John's name. You didn't give me John's name. You gave me Lisa's name. That's integrity. It doesn't represent the name of the person who am I looking for. Okay, so it's supposed to represent whether it's a name of the person or a place accurately as it is. Okay, so this is what you look for data validation. The next is provisioning, making data available. So a data engineering framework should allow you to take data from the source, make it available for machine learning models, make it available for predictive analytics, make it available for data analysis, reporting, application. And that is what data engineering does. Okay, that is what data engineering does. A data engineering makes the data available from the source all the way down to application. The steps what I listed, it could vary. Okay, what I put, it's a very high level step. What I put, it's a very high level step. It could change. But bottom line, this is what I told. Make data available. Okay, make data available from the source to the application or to the analytics. Using what? Using modern technologies. Using modern technologies. So what are the modern technologies we have talked about? Traditionally, what we do, we use human intelligence driven hard-coded business rules. Instead, use machine learning. What exactly it means, we already talked about it. Okay. In a traditional world, what we teach students, to read data from a table, we tell students write a simple SQL statements. Okay. I still remember my, the things that what I learned with Oracle almost 20, 25 years back. Okay. So what I have been taught, okay, the small correction, this is supposed to be sum. Okay. So I have been taught, if I wanted to get the salary that's been paid for a particular department or a commission paid for a particular department. What you have to do a group by of the department and do a sum function. This is what I was taught in first day of my Oracle class back in Chennai. Okay, 20 years back, I was taught by this instruction. So if you want to read data from a table, and instead of going out looking at, write a simple select statement which will give you. So in this case, it's a traditional approach. Select department, sum of salary, sum of commission from employee, where country equals India, group by department. There's nothing wrong in this. It works really well. But what's the problem here? It's a human written, and it's a hard-coded rule. Country equal to India, that's the hard-coded rule. Okay? In data engineering, we don't want to do these things. It's a traditional approach. It's a traditional approach. In data engineering, what I'm saying, instead of writing these kind of hard-coded rules, use machine intelligence. Something like k-mean clustering. What does k-mean clustering does? It groups the data which has similarities. Okay? It groups the data which has similarities. It does this one. So use this kind of technique instead of traditional approach. Use this kind of technique instead of traditional approach. So here's the problem. Tomorrow, I don't want India. I want to use China. Then I have to go back and change the SQL. That's ridiculous. Okay. Here, the machine learns itself. When it sees China's data, it groups all the country together. China will be formed one group, one cluster. And within the cluster, it goes and does other things, correct? So, but the point is, I'm not hard coding country China, country India, and so on. So this is what modern approach is. Okay, the modern data engineering approach do not dependent on human. Don't use hard-coded rules. Instead, use a machine learning approach such as k-mean clustering or KNN. So I hope this makes you understand how does data engineering apply in a real world. Correct? Instead of going on a traditional hard-coded way, use machine intelligence where it self-learns. When a data set changes, so now I'm not getting country India, but I'm getting country China. How big of a deal it understands, correct? Instead of China, I'm getting India. Let's group all the China together. Let's group all the India together and form a cluster and work within the cluster. Okay, so this is basically a fundamental change. I do have an assignment. Does KNN, K nearest neighbor, and K means clustering fall under either a classification problem or a regression problem or something else? So what I'm asking you for, we implemented linear regression. So linear regression, it's the regression problem. It is a range of value that what we predicted. So here I'm asking, the k-means clustering or a KNN falls under what kind of problem? Is it a classification problem or a regression problem or something else, or it's both? What it is, correct? So I want you to find out, you let me know so that I understand, you understood. Okay, let's move on. All right, so when we say data engineering platform, what does that involve? A data engineering platform involves, typically, I'm not saying always, at least based on my experience, correct? So when you want to work with data engineering, most cases you deal with all these three platforms. An IoT platform, where you have sensor device level interfaces, and a big data platform. How do you store and process massive volume of data? And an AI platform where you can run models and stuff like that. So typically, data engineering platform, a combination of all the three. I said typically, not always. It's all based on what kind of problem solving or use cases you are building. Some of the courses you said, people said that they took Udacity, Coursera, on all these places. So they may not expose all the things in a real world, okay? In our case, we have use cases which touches all of these things, okay? In our case, we have use cases which touches all of these things, correct? Which has an IoT platform connect to the device level and a big data platform. It goes and processes the massive amount of data, an AI platform, okay? So there are certain things you need to understand. IoT is not really for data storage. IoT is primarily for collection, data collection. So example, you have an Apple Watch, okay, or you have a Fitbit device. So what that does, it keeps tracks whatever you do, how many steps you are taking, how many steps you are walking, what kind of drinks you are taking, etc. It tracks very much everything. So how do we read such data? Yes, because you are moving, correct? You are not sitting in a place in a static, correct? You are going to India or US or China, wherever you're going. But still, I want to track this one. How do we connect such device and read the data? That's what IoT does. Okay, that's what IoT does. Once I read this data, correct, I can walk 1,000 steps. I can walk 10 steps. I can walk 2,000 steps. So you see, I don't have any defined number of steps that I'm going to take. It doesn't matter how many steps you take. I want to store all the things. Then I need a big data platform. And I need a big data platform. So in summary, when people say data engineering, that will involve all the threes. You should be able to work with device level data sets. You should also be able to work with very large complex data sets. Okay, very large complex data sets. Okay, so IoT focus on primarily data collection or data production. It produces the data. Big data focus on data management. Correct? It stores the data, processes the data, retrieve the data. Okay, and the AI, it consumes both the things. Data that comes from IoT, whatever stored in big data, it takes them and processes them. For machine learning, deep learning, computer vision, natural language processing, robotic process automation. Okay, extract hidden insights, builds intelligent automation, data science. I'm sure you all know what is this volume, velocity, and variety. I don't have to tell. So in case if you don't know, take an example of Facebook. How many people can come to Facebook? No one can control. One could be 1,000 at any given point in time. It could be 1 million. Correct? As a platform, it supports. And that is what the volume. The number of people who's coming to Facebook, the number of people who's coming to platform like Twitter, it's not controllable. Okay? You'll never say, oh, you reach the limit, wait for some time, then come back later. It never said that. So it dynamically expands. It dynamically expands based on the volume. So the second, velocity, the speed in which it happens. Okay. Example, morning 10 o'clock, 1 million people. 10:05, 2 million people. 10:10, 15 million people. See the speed, how it goes, correct? It's just uncontrollable. Okay. What kind of data you put on Facebook? You can put video, you can put voices, you can put text, you can put images, you can put anything. Nobody asks any question. And that is what variety. Okay, that is what variety. When people talk about big data, you have to understand you are dealing with large volume of data, which comes in a rapid speed with different variety. It could be image, it could be voice, it could be anything. And that is the things we talked about. So when we say variety, it could be structured data, unstructured data, semi-structured data, videos, image, voices, correct? So that is what this does. Okay, that is what this does. So what I'm trying to say, when we say big data, okay, when we say big data, so what we are talking about, we were talking about when we take data engineering platform, we are talking about these three platforms together. In a real world, typically, when we are working with data engineering, you are working with typically an IoT platform, big data platform, and AI platform together. And that is the real need. Move on. So what are the different technology we use? Again, I'm not trying to say that you have to master all of this. So each one have its own technology. Someone asked me yesterday after the class, they called me, oh, I like the class, everything is fine. I wanted to be a hands-on expert. Where do we start? I already know Python. Okay, just knowing Python, can I be an expert in this space? Impossible. Impossible. Why? It's so complex. There's a lot of things involved. Okay, so just Python is just coding here, but build an end-to-end solution. Correct? For example, okay, so I'm showing you this one. Correct? So what I showed you, building something at this level, building a predictive model for a CFO. Okay, building a predictive model for a CFO. It is not an easy thing to do. Correct? So someone sitting in an office, based on my sales, okay, based on my sales, I'm trying to calculate my net income. If my sales goes down 2%, what is my net income? If my sales goes by 5%, what is my net income? If my sales goes down, then what is my gross profit? Okay, building at this level, okay, this level of automation, This level of intelligence, this level of analytics, it requires all these three platforms to work together. Okay, so there are so many different technologies involved at each level. So it is not that easy someone to become an expert overnight. It's absolutely impossible, especially with this premature area. Okay, it is not a mature area. So I'm just going back to share my PowerPoint so that you can understand. So all I'm trying to give you, these are the different technologies. In our case, the model that what we implemented. So what we used Python and TensorFlow. Okay, we used Python and TensorFlow in our session today. Okay, so we demonstrated how do we implement the 6-month rolling forecast. Okay, you see this one. So this is the model we implemented. What is this? It's a Python program. And what model we used? Scikit-learn, sklearn. You see this one? sklearn. So I'm going back to the PowerPoint. Okay, so stop. I'm going back to the PowerPoint. So that's just one piece of it. Okay, that's just one piece of it. There are so many other things involved. So I'm not saying you have to master all of those things, but at least as a teacher, when you teach the student, we should guide them and tell them, boss, this is what involved in the real world. If we want to be an expert, make sure you understand all the things that is listed here. Okay, at least understand. Okay, so when it comes to big data, I'm sure you all heard about Hadoop. Okay, you all heard about Hadoop. So that's one of the most dominant platform for people to use. Okay, hold on. So that's one of the most dominant platform for people to use. Okay, so when it comes to big data, so what I'm talking about, Hadoop. So this is one of the most dominant platform people to use. So I would say learn these things also. Okay, to the best whatever you can. To the best whatever you can. Why? That is where you store and process huge amount of data. Okay, let me check this chat window. Stored and automatically. All right, there's some use case. I will respond this later. Okay. All right. So now we understand there are different technologies involved. Like I said, you don't have to really master. At least keep this on the back of you as a notes. You can tell students what is HDFS, Hadoop Distributed File System, what's Yarn, Resource Manager, MapReduce. It's an programming aspect, is a distributed data processing. Okay, distributed data processing, Spark, Pick, Hive, HBase. I can read all the things, correct? So it's good for you to read instead of me, so that you can understand. So when someone says, I want to be a data engineer, okay, so at least people have knowledge of all the things. They should be able to work with all different things. Okay, so this is what involved. You see the underlying, the IoT deals with Apple Watch, Fitbit, health monitor, lifestyle monitor, fitness monitor. Basically, it should be able to connect to a device, read the data, and it also able to connect to any machine and read the data. Can anyone give an example? In oil and gas industry, where do you use IoT? In oil and gas industry, where do you use IoT? If you are not sure on oil and gas, can you tell me in healthcare, where do you use IoT? If you are not sure on healthcare, can you tell me in energy, where do you use IoT? My question is, in the context of data engineering, in health, energy, oil and gas, where do you use IoT? I just need one example. Okay, anyone? In the context of, okay, patient identification during medical emergency, integrating patient structured data. To deal with structured data, Ratika, we don't need IoT. Okay, we don't need IoT. Okay, so for example, in the field of healthcare, you already heard about electronic medical record. Okay, electronic medical record. What is electronic medical record? So now the world is leading towards storing everything in a digital form. All the medical record, such as lab work, blood work, medical X-ray. So these are all stored electronically in a digital form. How do you read that? And that is where IoT comes into picture. Okay, how do you read this? I want to see the patient medical X-ray which was took last month. it is not a hard copy. I wanted to read them, which is stored in an EMR, electronic medical record. To connect and read that, I need a device. And that is what IoT device. Okay, that is what IoT device. For example, if you wanted to go ahead and look for things around the oil and gas industry. In the oil and gas industry, the drilling machine which drills the oil on the oil field, I want to remotely monitor the temperature. I also want to see how much oil it's producing. If it's not producing any oil, I don't want to drill this one. I want to stop this one. If it reaches a certain pressure and temperature, I want to stop this one. So how do I connect these kind of devices and monitor this? Okay, that's IoT. That's IoT. In an energy field, okay, in an energy field, example, we have a room of people. They leave the room, but they forgot to turn off the lights. Now the lights are on. Now the lights are on. I wanted to see if anyone in the room or not, so that I can take control and turn the lights off. How could I connect the room? I need a sensor. Okay, I need a sensor. So the device which allows you to connect to the sensor and read the data, what is happening in the room, that's IoT. That's IoT. So keep in mind, IoT plays very dominant role. Okay, IoT plays very dominant role. So you don't have to memorize and make all the technology as an expert, but at least you should be confident enough to talk about it. Okay, all right, let's move on. So the next topic, what I want to talk about, in data engineering, you work with data streaming. What is data streaming? What is even broadcasting? Okay, so that is also one of the things that what you do in data engineering. For example, when you're sending a cell phone text, whatever you type, I want to read them. That is streaming the data. Okay, whatever you type, we want to connect and read the data. Okay, so that is combination of IoT, data streaming. IoT or data streaming. So for the security cameras, if someone walks in, we want to connect and follow them, what they're doing. Okay, wherever they're going, I want to follow them. So that means the people who's monitoring the security camera, they're sitting outside, okay, not in the building. They're watching this one. How does the camera movements is being tracked and streamed? Okay, so that is kind of a combination of IoT data streaming. Any post that you like, if someone posts, okay, somebody posts something in Twitter, you want to know. Let's assume I want a restaurant business. If someone goes and talks about good things, bad things about this restaurant business, I want to know immediately. I don't want to go and read this after 2 months or 1 month. If someone talks about business, such as restaurant business, I really want to know as and when the posting occurs. I cannot really wait for months and go and read. How do I do? I want to broadcast something like this. I want to subscribe something like that, correct? So these are the things falls under data streaming. Okay, an example that we could think of using this, we talked about conversation-based customer engagement, that one thing. The most commonly used, all the political people talk about fake news. Okay, so what it is, if someone publishes a news, you can tell, is this news is fake or not? Okay, if someone talks about something, if something, you can do factual check. Okay, you can do factual check. The moment you find, okay, the moment you find that is not true, you can say it's a fake news. Okay, they're faking out. So that means whatever they speak, you string them as and when the speech occurs. If they write, as and when the write occurs, you string them. The moment you string, you run a machine learning model, which goes and looks for, is that something that happened in the past? Is there anything like this? No, I don't find anything. Then that means it's a fake. Okay, all right. So this is also part of your data engineering. Okay, this is also part of your data engineering. Data streaming is also part of your data engineering. Okay, all right. The next one, what you need to understand, data lake. Okay, what is the data lake? Keep in mind, these are all terminologies you come across in data engineering. Okay, you come across data. Oh, I forgot to tell you, Apache Kafka. Okay, what it does, so it allows you to connect to all the devices and streaming data. Okay, you can connect to, through IoT, you can connect to a device. Then using Apache Kafka, it's like in a software program, or an API or a library, whatever you want to call, that's fine. Using that, you can stream data, either from a cell phone or a post or camera, whatever it is, correct? So that's an open source product. So you can learn about more Apache Kafka. So this is what industry calls data lake. Okay, so what is industry trying to do right now? So typically, if you look at VJIT, every department have their own set of data. Okay, every department. Computer science department have their own set of data. Mechanical engineering, civil engineering, artificial intelligence, IT. Okay, in their own database, they have number of students, assignment, quizzes, this, that. How do we centralize? Okay, at the college level, across all department, I want to have only one single centralized database. Okay, and that is basically the concept behind data lake. Data lake provides a centralized data platform across all different functions of the business, location, time, currency, etc. Okay? It doesn't matter where you are, whether you are in India or UK, US, it doesn't care. Company Walmart will have one single centralized data lake, which provides data for anything, everything, what you need. So right now, industry is leading towards, okay, industry is leading towards creating something like data lake. If you see my previous slide, when I move this, when I get this data, when I stream the data from cell phone, when I read the data, where am I storing? I'm storing a data lake. On top of the data lake, I have the machine learning application which is running. On top of this, I have a machine learning application which is running. Okay. So point is, when you're working with artificial intelligence, data engineering, I'm absolutely confident you involve data lake. Okay. So what is data lake? Creating centralized data repository across all the business needs in a business. Take an example, your institution, VJIT, have a different department. Each department have its own set of data, such as the number of students, quizzes, assignments, coursework, faculties, HODs, etc. How do we collect all and put it in one single database? And that is the concept behind data lake. Once it's there, anybody, everybody can access. It simplifies the time it takes to manage the decentralized database. And it gives more efficiency. It gives more power. For example, the computer science faculty wanted to see who are the faculties available in artificial intelligence. The artificial intelligence faculties available, who are all teaching today in the IT, correct? So in that case, either you have to call them or you have to go and see the database. Instead, if you have something like a data lake, anybody can access everything. Anybody can access everything. Of course, there is security involved. Of course, there is security involved. So this is what the idea behind of creating data lake. Okay. So in a modern world like this, in the world of artificial intelligence, in the world of data engineering, you do interact with data lake. Okay. All right, let's move on. The next topic is an assignment. I'm sure you all heard the term data warehouse. Okay, I'm sure you all heard the term data warehouse, no question. Okay, there's no question. If you say no, I would not agree. Okay, so I'm asking, what is the difference between data warehouse and data lake? Number one. Second, to develop an AI-based application, which one we need, data lake or data warehouse? So what kind of AI-based application? It could be a machine learning application, such as we talked about a conversation-based customer engagement, or a deep learning application predicting a length of stay of a patient, or a data science, go dig deeper and figure out what is there in the data. Okay, what is there in the data? So to build such application, do we need data warehouse or do we need the data lake? Okay, so that's what I'm asking. Please find out this. This is something that what I really think we have to have some knowledge about data model. Okay, so what is the data model need here? Okay, what is the need for data model? So what I'm talking about, we can't really bring data and put it somewhere. there must be some structure. Okay, okay, I'm reading the chat. Is data lake at one or more location? It depends on, it could be one location, it could be more location, but it's centralized. Okay, the idea behind data lake, make data available for everyone in the enterprise, all data all the time, point one. Point two, reduce the data management effort, such as involves replication, backup, recovery, all these things. If you have decentralized, you have to perform for each one. If it is centralized, it could be a one shot. Okay, it could be one shot. The next one is data lake is required because it saves money, time, resource, increase efficiency. Okay, increase efficiency. In my case, it is centralized, but it is mirrored. So that means when it writes the data lake, it also writes the backup. If one is dying, then the other one will take it. Okay, so typically people use Hadoop. What is Hadoop? It's a distributed file system. It doesn't write in only one place. It writes in a multiple place. Even if it's one thing goes wrong, it will pick up from the other location. Now, other disk or a device or whatever it is, correct? It's going to pick up from there. All right. So coming back, what I'm asking for us to do data science. Okay. So can anyone tell what's an MDM model, an ERD model? Don't say you don't know. I'm positive you know this. What does MDM stands for? What does ERD stands for? You can do Google. I encourage you. Okay. You can do Google. What does MDM stands for? What's ERD stands for? Any idea? So MDM stands for multi-dimensional data model. ERD stands for entity relationship model. Okay. So both are kind of traditional. Both are kind of traditional. Okay. When we are talking about building data science, we may not need the structure. That is the beauty of machine learning. It doesn't care whether the data in the form of a cube, whether the table in the form of a table. Okay, so what this represents a cube. Okay, cube. So we have dimensions and measure. There's a centralized fact table surrounded by number of dimensions. That's the concept behind MDM. ERD, it's a flat structure. There's rows and columns. Okay, there's a rows, and there's a column on the top. Correct? So there's a rows and columns. So point is, without doing any modeling, can I build machine learning or data science? Answer is yes. So when you are working with large complex data sets, you may not need all the structures. These are all traditional way of looking at something. These are all traditional way of looking at something. So you may not need all the things. Okay, you may not need all the things. So all I'm trying to say, as a data engineering, you do need to understand this one. Why? Why do I need to understand this one? That is because when you are going to get data from all the sources, either from SAP or from Oracle or from Microsoft or from IBM, there you will deal with tables. There you will deal with cubes. Okay. At that point in time, you do need to understand some of those traditional table structure, cube structure, and etc. So I'm talking about if you truly want to be a data engineer, where you can go and extract data from different sources. In that case, you do have to understand what does an MDM model look like, what does an ERD model look like. An MDM model, multi-dimensional data model, which is nothing but a cube. An ERD model, it's like a flat structure, tables and columns. Okay, but in order for you to function on data science or machine learning, deep learning, do you care for this? Answer is no. Then you are going into a traditional approach. The beauty of machine learning, it doesn't matter what form the data is. It still go and figure this out. It will go and figure this out. Okay, that is the beauty. I want you to understand, and that is why I intentionally posed this question: which model we need for data science? We no need both the model. It could be anything. It could be structured. It could be unstructured. It could be video. It could be image. Who cares? Okay, that is why we have different technique. We have natural language processing, which understand how a language has been written. That has no structure. It doesn't care about a cube. It doesn't care about an ERD model. Computer vision, it works on images, which works on videos, which works on voices, kind. that doesn't care whether it's an MDM and ERD model, correct? It works based on the image that what you provide. Business process automation, which is robotic process automation, RPA, that doesn't care about the table and all these things. It works on. It is easy to say what I said, but it's so difficult to do implement these things. Okay, it's so difficult to implement. Okay, if someone tells you you have to understand table, all this nonsense, no, don't worry. Okay, so the machine should be able to figure this out by itself. All right, what is next? So we do have a publication. Okay, I'm going to stop and share the screen. Okay, 1 second. So we are in the process of fine-tuning this. So what we felt in industry right now, there is no one written a book or written an article on data engineering. At least the level that what we are looking for. Okay, I have seen bits and pieces. I'm sure you have seen also bits and pieces. So we are in the process of publishing this article. Okay, so I'm still working on it. And DP is also working on this one. So hopefully we should be able to publish this soon. All the topic that what I talked about, okay, all the topic, it starts from data engineering. It starts from data governance, okay, that's unit 1, data quality. And then it goes to data collection. And then it goes to data streaming, okay, and then data integration. And then it talks about data mapping. And then data conversion, data validation, all the topic that what I listed, data provisioning, distributed data processing, in-memory data processing, working with structured data, anything, everything you could name. So it will be in this article, okay? It is not ready yet. It needs maybe 1 or 2 weeks of time. I'm not able to find some time. So once it's published, you can take this and learn as much as you can. I can bet there is no such article in industry history written at this level, okay? So as I said, there could be bits and pieces which is lying here and there, but nothing solid at this level. So I would say, give me 2-3 weeks time, I will send you this one. So if you can understand this, then you can also teach well. I would encourage the college should consider offering courses on data engineering. Do not simply teach Python. Do not simply teach data science. It's meaningless. Without this, you won't be able to do anything, correct? Then you will become 10 among 1. We want to stand unique. We want to be different. We want to add value. And this is value creation, okay? This is value creation, all right? So this is my last slide. And I'm kind of done. I just wanted to make one closing remark. Then I'll hand over to Dr. Divya. In my life and what I've seen people, knowledge is the power, okay? Knowledge is the power. There's nothing beats knowledge, but we have to be smart enough how to use this knowledge, okay? We have to be smart enough how to use the knowledge. The more knowledge, the more power, the more thing you gain, whatever your passion, okay? Your passion is money, you can make money. Your passion is like become a top-notch industry professional, you can. Very high-profile person, you can. Knowledge could be anything. Knowledge is not only artificial intelligence. Knowledge could be speaking, correct? Knowledge could be acting, whatever it is, correct? So whatever the field it is, the knowledge what you gain, it makes you more valuable, though makes you more unique, okay? More unique. So I would encourage whatever we spent for the last 4 days, it may not be in a full-blown course, but at least it gave you a framework for you to operate. So we can't jump 1,000 feet at the same time. We can jump small steps. Take a small step and continue the small step. It will become a bigger steps. Today, 100 feet. Tomorrow, 200 feet. Day after tomorrow, 300 feet. You will achieve 1,000 feet one point in time. But the effort that required to continue to practice, it's quite significant. It's not anybody can do this just like that, because we all family people, we have family commitment, personal, professional, all these commitments. In spite of all finding some time to do this kind of learning, it's not easy. I understand that part, and I've been there too. So with all the things, whatever happening around you, if you could find some time and spend on all the topic that what we covered and make yourself comfortable and do the practice, the linear regression model that what we implemented, if you practice that kind of models by yourself, that makes you very valuable. Okay, that really makes you very valuable. You don't have to price me, but I'm sure you all have seen a clear difference on what you've seen in market and what you have seen here. Okay, so I really want to make a difference along with you. I'm willing to work with you all, and Deep Spirit is committed to make you all to be very successful. I really want to thank you for the opportunity. Thank you all. Wish you all the best. Good luck. Thank you so much.
Thank you, sir. Sir, there's a query from Sharan Basappa.
Sure.
What is the flow of work recognition of food objects from advertisement billboards?
What is the flow of work recognition of food objects? I'm not clear on this question. Okay, what is the flow of work? So, are you talking about when in a food industry, correct? How the food orders taken and how it's been delivered? Is that the question, or how do you build machine learning models around this one? I just wanted to know. Are you talking about a business process? Are you talking about implementing a machine learning model or an artificial intelligence type of solution on the food industry? So if I read the question, what is the flow of work recognition of food objects from advertisement billboards? I really don't understand the question.
Dear participants, I can see your hand, Dr. D. Radhika and KCB sir. You can unmute your mic and ask question.
Hello.
Yes, ma'am.
Hello. I am KC sir from Guntur.
Yes, ma'am. Yes, sir.
I am associate professor in the Science Engineering College in CSC department.
Yes, sir.
I think sir, if you will do extension feature better education with using data engineering in artificial intelligence.
Sir, by default, artificial intelligence, as I said, whether you work in artificial intelligence or a machine learning kind of a work or a data science kind of work, the inbuilt expectation, you must have to know data engineering. Okay? So data engineering by itself could be a skill, but if you want to go and become a data scientist or a data architect or an artificial intelligence kind of a person, subject matter person, the expectation is that you have to know data engineering. That's inbuilt. You cannot say no to that.
Thank you, sir. D. Radhika, over to you.
Thank you, ma'am. Hello, sir.
Yes, madam. How are you?
Sir, am I audible? Hello, sir.
Yes.
Am I audible?
Yes, ma'am. Yes, ma'am. You are crying.
Maybe some other. I'm Radhika.
Yes, ma'am.
Sir, can
Yes,
I speak?
Of course. It's a free platform. Anybody can speak.
I always. Yeah. I always had one doubt when I was comparing theoretical concepts and programming. When I observed a neural network, number of layers. So, what or not? You please tell your opinion.
Sure.
Input, let me give whatever is the input. In between layers, which will support. Each one is the programming layer. They will take the input, process that layer. Let us say 5 programming layers are there. One programming layer will process that, give it to the next programming layer as an output. Like that, they will subsequently pass all the outputs to the last layer. If at all we are not getting the expected output, we are getting the programs in between, so that we are getting the output. Am I theoretically understanding it correctly?
You are absolutely right, ma'am. That's how the deep learning model works, ma'am. That's neural net. Yes, ma'am. If you are talking about neural net, that is how it works. That's a fundamental architecture.
And you were asking about you. Yes. Yes. I was just comparing it with theory.
Okay, Dr. Rangaswamy, you switch on your mic.
Hello.
Yes, Dr. Rangasamy.
Sir, there is something disturbance coming to the Radhika madam. Okay.
Yeah, so I can't hear what she's saying, but I just told her, she asked about the neural net architecture. When you have different layer, the output of layer 1 goes to input of layer 2, the input of, hello?
Yes, sir. Yes, sir. Okay.
So she's describing the architecture of neural net. I said that's how it works. She said it's a theoretical. I said practically how it works. That's how it works.
Yeah. Yes. Just I want to make sure that it is clear or not. Okay.
Yeah.
Okay.
There's a question from Bhikshapati, sir.
Yes, ma'am.
What is the correct order of learning through the technologies in order to become an AI engineer, data scientist?
Sure. So the order, I would say, data plays a very key role. Okay. Data really, even if you want to build a model, you can build a model, but that may not produce in a higher accuracy, confidence level prediction. Okay. Whether you use machine learning, deep learning, it's all going to read from a data. The starting point, I would say, understand data, work with various data structures. Take simple problem, see what kind of data you need. Like one of the things that what I put in the class, if you look at, okay, 1 second. So one of the things that I told in the class, like, you know, so there are different type of data that is involved. I also mentioned an assignment here. So how to connect all the 6 data sets. Okay. One is video, one is image, one is text, one is structured, one is unstructured. So think about it. So what it takes to connect this one, what kind of technology is involved, and how do we deal these things? So think in that way. Second, come up with a use case. Where do I need all the things? So the starting point, at least for me, I'm not saying for that's how it should be. You have to start from data, understand the data structure, work with various data sets, try to create a training data, try to create a task data, correct? Like that, work with very large complex data sets. I can bet either in Hyderabad or anywhere in the world, and the US or anybody place, there's no single institute which teaches you data engineering. Absolutely no. Okay. So that is the biggest challenge in industry at this point. Start from there, understand, then you can go to the model part later. And of course, we all need to understand the business domain. So that could be an area of focus. But the starting point, try to understand how to work with very large complex data structure.
Thank you, sir. Last question from G. Kalpana.
Yes, ma'am.
Can you name few auto AI tools which are available in the market to run all these ML, BDA, IoT applications?
Deepsphere.ai. So there is no tool exists, ma'am. Otherwise, this will be simple. Okay. So this is basically a premature area. When I say premature, people can talk about it, but when you go and look at this, there's not much out there. Okay. So there are tools specialized in each of those areas, correct? There are tools focused on just modeling side, creating model, training model, testing model, deploying model. There are tools available. And other companies heavily focused on data, such as working with images, videos, voices, and etc. So there is no an integrated platform where you can see everything. Correct? There's no one single integrated platform, and that is missing. So that may be the one DeepSphere is going to build, correct? Which we are doing right now. So answer to you, partially DeepSphere. There's nothing in industry at this point.
Thank you, sir. Before we conclude, I request the participants, if any one of you want to give a feedback on this session or the topics, always welcome. We would be very happy to hear from you.
Yes, I really want to hear at least from one or two. How did the session go? Did we do a good job or a poor job? So I really want to hear from you.
So no one want to speak?
Divya madam.
Sir.
I request someone to join, give the feedback.
It was a very short time, but hello,
Yes,
sir.
ma'am. Yes, ma'am.
In a very short period, in 4-day session of 2 hours each, I really felt I gained a lot of conceptual clarity. It was a heartfelt. It is a very. Thank you so much.
Thank you, madam.
Thank you, ma'am.
Madam.
Sir,
Now,
sir, you can speak, sir. We can hear you.
instead of asking the tool, they can ask the just what the institute. This will give the complete information is deep here.
Okay, sir. Thank you, sir.
Thank you, Dr. Rangasamy.
Sir, okay.
Okay. Thank you, Mr. Jyoti Periyasamy, sir. We are having a great opportunity to listen to the words by a great knowledgeable person. Thank you very much, sir, for sharing your profound knowledge with us. Your session was full of zeal and valuable information. Thank you once again. Now, may I request our principal, Dr. Padmaja Madam, to end the session by closing remarks. Over to you, ma'am.
Good afternoon. Hi, Jyoti Pariswamy and Geeta ma'am. And let me just, sorry, I could not join the inaugural session due to we have an unexpected meeting on that day. Let me just, I would like to thank all the faculty and scholars of the Global Faculty Development Program organized by the CSC Department of Vijayajyoti Institute of Technology. I'm sure for all the attendees, computer professionals here, to discover the art of teaching artificial intelligence to teachers. It is certainly my honored privilege to propose the vote of thanks for this global FDP program, commenced on 8th, which has informatively appealed to all the audience until today. I could join for the last few minutes session. It was very informative for all the computer professionals from various colleges. I definitely feel assured that this FDP program has satisfied the knowledge hunger of all the attendees, as we have with us the visionary of technology, Mr. Jyoti Periyaswamy, Chief Architect AI and Data Engineering, and co-founder of DeepSphere AI, who has pondered on various aspects, providing a deep foundation on enterprise of AI from the problem statement to a successful implementation based on real industry-specific cases. How AI changes to the educational system at curriculum level and also assessment point of view. And the most revered academician, Dr. T.V. Geeta ma'am, Senior Professor, Computer Science and Engineering and retired Dean, College of Engineering, Guindy, providing deep information on the required skills and knowledge to apply in implemented products and solutions and gain a learning experience to become an AI subject matter expert. I take this opportunity to express my gratitude and sincerely thank Mr. Jyoti Pereswamy for accepting our request. He was in touch with me, I think 2 months back. We could not conduct immediately because of syllabus completion and all. Finally, we could conduct in this month. I thank once again Jyoti Periswamy. We are very much indebted to you for sharing your valuable time in enlightening all of us and all the professionals who have attended this conference, FDP. with your knowledgeable inputs, and I'm sure all the attendees have greatly benefited by being your audience. I would like to wholeheartedly thank Dr. T.V. Geeta for her acceptance to this program as a resource person. I would like to express my deep sense of appreciation for the excellent coverage Dr. Geeta has given for the last second day of the FDP on the domain of AI, and her knowledge shared with all the attendees has given to a deep understanding of the concepts. I would also like to thank Dr. Vijay Kumar, the head of the CSC department, and also Dr. Siddharth Ghosh, head of Department AI, and Professor Srinivasulu, Department of IT head, for their support in organizing this program successfully. I would like to extend my thanks to all the coordinators, Dr. Aruna Kumari, Mr. Praveen Kumar, Mr. Venkateshwarlu, for their consistent coordination in the conduction of the program. I also thank Ms. Divya, CSC department, for coordinating with experts and also moderating all 4-day session, introducing all the sessions of this global FDP. I extend my endless thanks to the managements of Anurag Group of Institutions and Vidyajyoti Institute of Technology for always giving their steady and unfailing encouragement and support for organizing events of such great magnitude. We are happy that the program is a grand success, and it can be seen in the resonating response from the delegates participating from various colleges and universities. I believe around total 153 attended this FDP program from 37 different colleges and universities. That is a remarkable this thing in this FDP. Last but not least, I thank all the delegates of the Global Faculty Development Program for making the event a grand success. As said by Jyoti Periswamy, learning is a continuous process, and hoping that all the attendees of this FDP program would take at least some baby steps after going back to your respective colleges towards artificial intelligence domain. Thank you once again for CS department for giving this opportunity to say the valedictory remarks for this FDP. Thank you all.
Thank you,
ma'am. So I just want to make one small comment or thoughts to share. I have the DSphere co-founder join the call. His name is Mr. Ramaswamy. Mr. Ram, are you there? Mr. Ram, can you hear us? Looks like he's not there, or he may be in mute. Anyway, so I wanted to thank him as well for this opportunity that he's provided us. So he's the investor and founder, co-founder as well. So I asked him to join the call. He said he's joined the call. Anyway, thank you so much. Thank you so much. We truly appreciate everyone's support and commitment and help to get there. And as Madam said, it's definitely a remarkable accomplishment within the short period of time. Once again, I really want to thank you all. Thank you so much.
Thank you, sir. Thanks for your time and patience.
Of course.
Praveen sir, do you want to give any instructions or?
No, just one small instruction, ma'am. Actually, as everyone knows that like our director is changed for that reason. Just we'll wait for one week to get the e-certificates. Please be patient and don't call me for the sake of certificates till a week. After that, you can call me. No problem. That is what I want to conclude.
Thank you, sir. Now we'll end this session.